So this is probably the first video in this channel. So today we are going to discuss and look through the questions for the SPM trial paper from the state Johor, Batu Pahat. So let's come to the first question. So table 1 shows the proton number of the elements P, Q, R, and S. So as what I suggest, the student can use the highlighter to highlight the keywords in the questions to avoid misunderstanding or overlook from the questions. So it's given that we have the elements P, Q, R, and S. So the question asks us to identify which pairs of the elements has the same number of valence electrons. So for your information, valence electrons is the electrons in the outermost shell. So for example, let us look at this one. So for example, this is A, and then okay, we just simply draw. Okay, so let me ask a question. So 1, 2, 3, which number do you think is the valence electron shell? So from what we said, valence electrons is the electrons in the outermost shell. So definitely this one, 3, is the valence electron shell. So the valence electron will definitely be the electrons in this shell. Okay. So this is a quick tips. So I will just write the electron arrangement for each element. So for P is 2.5. Okay, for 8 is 2, for Q is 2.6, R is 2.8.7, so S is 2.8.5. So this is the standard or typical electron arrangement that we should write if the questions ask us to do so. So the only number that we should observe is the last number, which is this one, 5, 6, 7, 5. So definitely the elements that has the same number of valence electron will be P and S, because they all have the 5 electrons in the outermost shell. So the answer will be B, P and S. Okay. So question 2. Which diagram shows the weakest force of attractions between the particles? So force of attraction is meaning refers to the atoms, how the atoms is arranged to each other. So we are given A, B, and C. So we need to observe A, B, and C, so identify. So I believe that you all learn from the 3 steps of properties of the matter. So for sure, solid, we have solid, liquid, and gas. So among these 3, which one has the weakest attraction between the particles? The answer is gas. Why? Because gas consists of the freely moving, freely, and randomly particles. The particles are moving freely and randomly. So which one will match this statement? So the answer is C. Definitely this is gas, because you can see there are many spaces between these arrows from each other. So the gas has the weakest force of attraction. For your information, you can look at A. Even though they are still stick together, but there are also some spaces between them, between the particles. So this is the arrangement is not that packed. So this is A is liquid. So for B is, you can see B is arranged very tightly without any spaces and in an orderly manner. So this is the typical pattern, typical arrangement for the solid particles. Okay. Question 3. A patient has been diagnosed with cancer. Which isotope is used to treat the cancer? So for your information, you need to remember what is isotope. So isotope is refers to the same types of elements that has the same proton number but different nucleon number. So which isotope is used to treat cancer? Okay. So this one we need to memorize. No, there's no choice. This is considered as an easy question that you only need to memorize some famous examples. Yeah, that's it. So the answer is D, cobalt 60. It is used to treat the cancer. So for your information, carbon 14 is used to identify the age of the artifacts. we can use it to determine the half-life remain in the fossil fuels or anything else, and then we can use that to trace back how old or how old is the artifacts or the fossils. And then sodium-24, if not mistaken, is used to test the whether the pipe is leaking or not. Okay. And then phosphorus 32 is used to identify the what I remember it's related to plants, and maybe it is related to the nutrients obtained by the plant. Okay, let's look at question 4. So question 4 is, which of the gases contain 0.6 mole of atoms at room temperature and condition? So the first thing we need to identify is the number of mole that each substance ABCD contains. So definitely we can observe that all the gas volume for ABCD are the same. So we only need to calculate one time for the number of mole. So number of mole is equal to the volume of gas divided by the molar volume of gas. So for A, B, C, and D, all are the same because the molar volume for the gases for all the gases is equals to 24 dm cube per mole. So since the volume of gas is 4.8 dm cube and then divided by 24 dm cube is equal to 0.2 mole. Yeah. But we need to identify the 0.6 mole of atoms. So we need to calculate how many atoms are there in A, B, C, and D. So for neon, it's only one type. It is only consists of one type of atoms, which is the neon atom. While nitrogen is nitrogen molecules, and the formula is N2. And then sulfur trioxide is SO3. Carbon dioxide is CO2. So each of them contains 0.2 mole of the gases, but of it. But we need to identify the neon. We need to identify. So from the calculation, we can already know that there is 0.2 mole content for each A, B, C, and D. But we need to identify the atoms. So here we need to refers to how many atoms are there. So for question 1, so A is 0.2 number of atoms, number of mole of atoms. So 0.2 times 1 equals to 0.2 mole. B is 0.2 mole of atom times, here is N2, meaning that it has 2 atoms for the nitrogen molecule. So it's 0.4 mole. For C is 0.2 mole times 4. Why? There are 4 atoms in one sulfur trioxide molecule. So the answer is 0.8 mole. Lastly, for D is 0.2 mole times, how many molecules are there? How many atoms are there in one carbon dioxide molecule is 3. Why? C only one C and two oxygen atoms. So O is 3 atoms. So the answer is 0.6 mole. So definitely the answer is D. Okay, let us continue with the question 5. Diagram 1 shows the chemical formula of potassium hexacyanoferrite trihydrate. So this question is asking you to find what is the relative atomic mass of this compound. Basically, this is just a simple mathematics questions for you. So you can calculate the relative atomic mass. So K is 39. 39 times 4 plus ferron 56 plus 6, why? Bracket of 6. Meaning this Cn, we have 6 set of Cn. So C is 12 plus N 14 plus 3 water molecule. Therefore bracket 2 hydrogen, 2 plus 16. So you need to sum up the question, you need to sum up the value. So the answer would be 156 plus 56 plus 6, 26 plus 3, 18. So the answer would be 422. Yeah. So if next time you guys look at this type of questions, so you can use this formula to calculate for the answer. So question 6 is diagram 2 shows an illustration between atom P and Q. So let's look at P. P said that it is in group 14 in the periodic table of elements, while Q is in the group 17 in the periodic table of elements. So let us look at the electron arrangement first. So for here, we know that group 14, it has 4 valence electrons, while group 17 meaning that the element has 7 valence electrons. So for your information, 4 and 7 meaning that they only can achieve a stable octet electron arrangement by sharing of electron. So meaning that the answer is D. Dative bond refers to you need to have a lone pair of electron, for example like this. This is Q and then it has a lone pair of electron, and then it can donate to the atoms that they're lacking of a lone pair. So this Q can donate its lone pair to R. Ionic bond is formed when atom A, it donates to B its electron. Metallic bond is formed when there's metal. So but in here we cannot know that 14 group P and Q is metal or not, so the answer will be D. So diagram 3 shows the apparatus set up to determine the empirical formula of a metal oxide. Which metal uses the same method to determine the empirical formula? So the diagram is magnesium. So as we know, magnesium is a very reactive metal. So which metal can be used to determine which element can be used the same method to determine the empirical formula will be zinc. Copper cannot, because it is less reactive and it is quite dangerous, so it needs another setup for that. And then iron and tin is also less reactive than magnesium. So the elements that are less reactive than magnesium need to use another method to determine the empirical formula. Find what is the formations of the hydrogen bond. So firstly, you need to have, the first condition is that the hydrogen atom must be bonded to a very electronegative atom. So in this case, you need to remember fluorine, oxygen and nitrogen form is the very electronegative atom in the periodic table. So and then these hydrogen atom need to also being attracted to another electronegative atom that has the lone pair. So for information, these two dots represent the lone pair of electron. So actually the bond, the dotted line here is the dative bond. Actually hydrogen bond is also can consider as a dative bond. So the answer is B. Why A cannot? So first, this is bonded to a electronegative atom, yes, but then it has no lone pair, so this is not a hydrogen bond. And then also this situation C is also the same as A. And then okay, we can look at D. This is quite interesting because this H is attracted to oxygen, yes, but then it is not attracted to the another electronegative atom in like this. This is O. So in this case, D is it is bonded to H. So H is, they are the same thing, so it's not electronegative and it has no lone pair too. Yeah. So which of the following, okay, question 9 is also related a bit to question 8. Question 9 is asking which particles are formed from a dative bond. So the answer is 1 and 2. If you already do many exercises, so you can quickly identify which particles is formed from a dative bond. So why I say so, okay, this one we are not looking to them. Actually, how this is formed by H2O plus a H plus, and then this ammonium ion, this is ammonium ion, is bonded to NH3 plus another H4, another hydrogen ion. So as what we say, if it refers to the definition of dative bond is actually you need a donor. Firstly, you not need a donor atom, and then you need an acceptor. We can say it as electron donor and electron acceptor. So if I want to donate something, so meaning that it must have lone pair. If I am an acceptor, I must have the empty orbital. So water, let us refer to one first. Water is like this: oxygen bonded to 2H, and then there is a lone pair connected, not connected, in the oxygen atom. So I need to donate my, and then this is a hydrogen atom, but it is a plus, meaning that it donates its electron to another atom first. So meaning that there is, like, this is the empty orbital. So this electron, it will donate an electron to him. So it will become it can bonded, because you already donate. If you donate electron, it will form a bond. There's a bond here. So this is the hydroxonium ion. I'm not sure whether this hydroxonium ion has this type of arrangement, but this is how it looks like. If you're interested, you can Google. So if ammonium is like this, also there is an N and then bonded to 3H. And then it has also a lone pair located at the N nitrogen atom. And then sure, there is also the hydrogen ion with empty orbital because of the plus. Plus meaning that you already donated electron, meaning you have no valence electron. That's why your orbital is empty. There's no electron. So this nitrogen atom will also donate its lone pair to the hydrogen. So when somebody donates things to you, there is a bond formation form, meaning that you will have a ammonium ion. It forms an ammonium ion, and then this type of bonding is dative bond. Yeah. Okay. 10. Question 10. Diagram 4 shows the electron arrangement in compound JL. So which elements is represented by J and L? Okay, we can see. Okay, first J is here. There is a plus sign and there is a negative sign. So sure, we can say that this is an ionic bond. And then ionic compound. Ionic compound has ionic bond. So this is 2. It means that it donate. It can be the group 1, 2, or 13. Group 1 and 2 is metal. 13 is also metal. So group 1 and 2, we have the famous examples such as lithium, sodium, potassium, calcium. And then for group 13, we have the famous example aluminium. And then maybe this one negative, we can say is group 17 metal, group 17 compound. So group 17 compound has fluorine, chlorine, bromine, iodine. So we can judge one by one. Lithium, okay, J is a possible, but it's not sulfur, because lithium and sulfur cannot form a compound. B is lithium, chlorine. Okay, beryllium and oxygen. Magnesium and magnesium oxide. Okay. But you can see that the electron arrangement for L is 2. The first orbital has 2 electrons, second has 8, and then third has 8. And then this one also 2. Okay. So you can refer to the periodic table which metal has only 2 electrons after it donates electron. So the answer will definitely be B. Actually, if it doesn't show you the electron in here, you can BCD is the answer. But however, we already know that J has only 2 electrons after it donates its electron, and L has 18 electrons. So definitely the answer would be B. Yeah. So we will only discuss the questions to question 10 first, and then we will continue after that.